Hi, let's talk about triangle mid-segment theorem. So if you have a picture of a triangle and you have a segment going across the middle, which indicates mid, that's why it's called mid-segment, that is telling you that the line that is parallel to it will create a formula. So in this case, I color-coded it. Segment BD is going to be parallel to segment AE. Notice it's not parallel to CE or CA, so you have to know what parallel means and you have to be able to identify the side that's parallel with that particular midsegment. The formula reads, the segment BD is equal to 1/2 of segment AE. So this piece, the yellow piece, is exactly 1/2 of the entire piece AE or segment AE. So let's see how that works using numbers. So say for instance I'm asked to solve or find, not solve, to find segment NP. So what I know is that this segment is in the middle of my triangle, so therefore it's called a midsegment. The midsegment is parallel to its base, and the rule or the formula states that the midsegment NP is going to equal 1/2 of its parallel counterpart, which is MQ. Substitute what I know. I know NP is what I'm trying to find, so I can either leave it as NP or I can replace it with X equals 1/2 of MQ. Well, I'm told that MQ is 18. So this simply means 1 times 18 and then take 18 and divide it by 2. So X is equal to 9, which is NP. So I could rewrite that NP is equal to 9, but it's the same answer, okay? And that makes sense if you think about the rule. If I were to substitute it in and I go back and I would place in 9 here for NP, because that's what I said it equals, should equal 1/2 of MQ, which is 18. Does that make sense? 18 divided by 2 is 9, right? So that makes sense. The next one, they're asking me to find y, and you will notice that the triangle is not always upright. Sometimes it's turned on its side. So what you're looking for is the midsegment. In this instance, the midsegment is segment BD, and you want to know which side is parallel with it. It's not EC, that's not parallel. So you again need to understand what parallel means. So segment BD is parallel to segment AE. So when I set up the formula, I know that the midsegment BD is going to be 1/2 of the side that is parallel with, which is AE. If you go ahead and write that down, it's so much easier to just go in and substitute what you know. Well, what do you know? You know that segment BD is 14. You know that the formula tells you it's going to be 1/2 of AE. Well, we don't know AE. We can replace it with Y since that's what it's asking for, or we can leave it as AE. So what I want to do is I want to get rid of that fraction. So to do that, you have to multiply it by its reciprocal. And since there's an equal sign, whatever you do to one side, you do to the other. So this is really just multiplying by 2, but just so you can see what's happening. I'm left with AE on this side, and then 14 times 2, which is 28. So I was asked to find y, which is AE, so y is equal to 28. And again, I can ask myself, does that make sense? The segment in the middle should be smaller. So that number is smaller than the number that you just came up with, which is the longer side that's parallel to the midsegment. And if I were to double 14, 14 plus 14, I would end up with 28. If I were to divide 28 by 2, then I would end up with 14. That's how you double check your work. I'm still using the same theorem, the triangle mid-segment theorem. However, I have expressions this time. So again, it is so much easier if you just go ahead and set formula as you know it. The mid-segment NP is equal to 1/2 of the side that is parallel with, which is MQ. Now go back and substitute what you know. NP is 2y plus 3. I know that it's going to be equal to 1/2 of MQ, which is 8y minus 10. If you ever have a fraction on the outside, what you're trying to do is get rid of that fraction. And in order to get rid of the fraction, you do the inverse, the reciprocal. 2 over 1. What I do to one side, I do to the other. But again, 2 over 1 is simply 2. And what I do on this side, because I have an expression, is I have to distribute this 2 to everything that's inside of that set of parentheses that you're going to make sure that you write so you don't forget that. When I simplify, 2 times 2y is 4y, plus 2 times 3 is 6. The purpose of trying to multiply by the reciprocal is to get rid of that. So I got rid of the fraction and I bring down everything that's in the parentheses, which is 8y minus 10. Now I can simplify by combining like terms. I'm going to subtract 4 on both sides and I end up with 4y. And then I'm going to add 10 on both sides and I end up with 16. So y equals 16 divided by 4, which is 4. So that's my answer for y. I'm then asked to go and find MQ. MQ is 8y minus 10. So I would just substitute this y in for the 4 in for y. 8 times 4 minus 10 equals, well, 8 times 4 is 32, and 32 minus 10 is 22. So MQ is equal to 22. And if I took this 4 and I substituted it here, 4 times 2 is 8, 8 plus 3 is 11. Would that make sense? If I took half of 22, would that give me 11? If it does, then that is my answer, because again, the midsegment is 1/2 of the longer parallel side. Its parallel side, because there's other sides that are parallel as well. So for instance, like here, you have a triangle within a triangle, so you have multiple parallel lines shown. So we're going to work in the order that's shown. So we're finding x, y, and z. If I'm finding x, I want to figure out, well, which midsegment is parallel with this x? Because I have a midsegment here, I have a midsegment there, and another one here. So I'm looking for the one that is parallel to x, and it's right above it, 16. So I know the formula says that IK, segment IK, which is my midsegment, is equal to 1/2 of the side that is parallel to, which is segment HL, and then I fill in what I know. IK is 16, and HL is my x. Again, I have a fraction I'm trying to get rid of, so what I want to do is I want to do the inverse. I keep saying inverse, I mean reciprocal. 2 over 1, 2 over 1 of this fraction. And then 2 times 16 is going to leave me with 32 equals x. So if I rewrote that, I'm just going to swap it around. X is equal to 32. Now if I tried to solve for, well, let's use a different color, for y, again, I'm trying to figure out, well, which side, and you may want to highlight or whatever so you can clearly see, well, which side goes with y? And do I have enough information to figure that out? I don't. I need something here. So let's just put a number there. Let's see here, y. We'll make it something easy. How about 24? All right, so again, I'm going to use my formula. I know that the midsegment, IM, is 1/2 of the side that is parallel to, which I have highlighted in orange, JL. And now I just substitute what I know. IM is what I'm trying to find, that's y, equals 1/2 of JL, which we just said is 24. And now you don't have to multiply both sides by 2 over 1 because y is already by itself. So on this side, you just simplify. 1 times 24 is 24. 24 divided by 2 is 12. Again, if I'm checking my answer, if y is in fact 12, is that half of 24? If it is, that is correct. Or 12 times 2, is that 24? So that's how I know I'm on the right track. And finally, let's find z. So z is over here. And I want to see, well, what's parallel to z? Oops, I don't know what's going on with my pen. So this mid-segment is parallel to z. I'm going to use my formula, which tells me that Km, segment Km, is going to be 1/2 JH. Substitute what I know. Km is 3.7. The formula says 1/2 equals 1/2, and then JH is what I'm trying to find, which we will call Z now. How do I get Z by itself? In this case, I do have to multiply both sides by the reciprocal. So let's do that. Times 2 over 1 times 2 over 1. Uh-oh. And once I do that, Z is by itself, and it's equal to 3.7 times 2, which is 7.4. And if you just want to rewrite it with the variable on the left-hand side, you can do that. Again, to test whether it's true or not, the smaller number is your mid-segment. The side that's parallel to it is longer, so it's going to be a larger number. Okay, so if I were to take half of this number, 7.4, and divide it by 2, I end up right back where I started, 3.7. Or again, if I double 3.7, which is multiplying it by 2, or 3.7 plus another 3.7, it does give me that 7.4. So this is how you solve for triangle mid-segments. So don't forget, please like and subscribe. Truly, truly appreciate it. Thank you.